I'm Frank. I might as well turn on my camera. I'm a developer specialist here at Microsoft. I sell GitHub. I sell Visual Studio. I help engineering organizations, right? Software delivery organizations, modernize and push features out faster and more frequently based on what we do at Microsoft and at GitHub. So I'm happy to have this conversation with you today. Software development is changing. We've been saying that for 10 years here at Microsoft, ever since kind of Satya came over, right? There's a lot of resistance to change, especially when you have very talented people that have skills that few people have, and they're, finding success doing things a certain way. It is sometimes hard to get them to change in a way that doesn't seem intuitive. Oh, one moment. Okay. However, delivery organizations that do kind of change to the more, I don't know, what do you, Silicon Valley kind of the FANG model of delivering software, really high productivity, very invested in DevOps and SRE, like those customers, those organizations perform better financially and in the market, right? So the shareholders are like, please change it, please modernize your engineering. And a lot of people look to us, right? I talked about inertia before. The tools sometimes can be confusing. I mean, nowadays it's a little bit easier to understand that like an AI or a machine can do things better than a human, but that is only very recently, right? People still want to trust their own human instinct and gut and spunk and all that. It's all garbage, right? The machine can do things a lot better than uh, a human can when it's a predictable activity that happens at high frequency. Definitely always bet on the machine, right? We do this. So ever since Satya kind of came around, Satya Nadella, our CEO, had a engineering background. So one of the first things he did is we're going to create a centralized modern engineering platform. I don't know. Do you know the name of our engineering platform? A lot of people do, right? It's One ES, or the One Engineering System. We publish papers on it, right? We have, what is that, almost 80,000. We're not the biggest tech company. We don't have the most engineers on the planet, but we have a lot. And we build a lot of different products. And we have a lot of repos, and we have a lot of, oh boy, a lot of stuff, right? A lot of custom stuff that eventually makes its way to market, like, I don't know, Copilot, right? We use it ourselves. Gartner loves what we're doing. Here we see kind of like Microsoft is definitely in that leaders quadrant, and for vision, like nobody has a better vision about this stuff than we do. Right? We're also a company that wasn't traditionally in Silicon Valley. Like we had to change into that model, so we understand that it can be difficult. We are going to talk about here about four little pillars of things. There's four kind of central ideas. First is developer tools. Developer tools have a big impact on your developer experience. We want to make sure that those tools are literally like in one kind, like we want developers to have a conversation with the changes or about the changes that they're about to introduce into a system, right? That's essentially what software engineering is. Handling a lot of changes and merge conflicts. And if I change something, I don't want your changes to break my changes and vice versa. Power to scale, we'll see how it's all kind of serverless in the cloud. Like you don't need to manage any of this stuff. And so just some tips and tricks about how to make all of this faster. Like this is what we want your engineering system to be: big enough, fast enough, modern enough, but easy for people to use and understand. It's all kind of discussion based. People will say, but Microsoft, how come you have Azure DevOps and GitHub, and which one should I choose? And like, this is a pretty good slide here. Like, this is what we would call our North Star. We use this exact model to build GitHub, right? Um, Parts and pieces, right? We use GitHub for very specific things. All of our open source stuff. If you think what is open source at Microsoft, it's a lot. The whole .NET standard, PowerShell, VS Code, right? There's a whole bunch of Kubernetes stuff that is open source. I think we have the most open source public repos on the planet, like more than the Apache project. Here we see for dev compute, like a virtual machine that would be your IDE. Here we see DevBox. if you need Visual Studio, right? If you're using VS Code, we would generally say use GitHub Codespaces, right? And then our platform includes Azure, right? Azure also is like Azure Boards, right? So even if you want to use GitHub, look into Azure Boards for your planning. Like it's a good way to maybe divide the work into smaller pieces. That's our platform: Visual Studio, GitHub, and Azure. All right, so now we have these four kind of topics that I'll talk about today. First is AI. Like customers are coming to us saying, I need GitHub Copilot. So let's just take a quick look at what that actually is. All right, most mind-blowing. It's basically the machine is able to write code. This research started way back in 2020 when we built for OpenAI. We built the fifth largest supercomputer on the planet, right? For OpenAI. And we were trying to figure out this problem too. We have Visual Studio IntelliCode, which is kind of trying to do solve this problem as well, have a machine write code. And it does okay, but it's nothing like what OpenAI has built over the last 4 years. Like that stuff has been around for almost 4 years now. Customers want to sometimes maybe build like their own GitHub Copilot. Like you're way behind. Take comments or even natural language, and it will give you back code suggestions. Oops, I'm getting some people popping in here. Autofill for repetitive code. So as you type, almost like IntelliSense, it will just go out and kind of guess what you're about to type. Show alternatives. You could do like, hey, show me a bunch of recommendations and let me kind of cycle through which ones I might want to use. Remember that GitHub Copilot is an interactive tool. It's not like OpenAI where everything's kind of like I send some files over to an API and then I wait for a response. No, this is kind of real time. We try to get those suggestions back to you in 200 milliseconds, right? In front of a skilled developer, skill being, the whole spectrum from junior to senior developer. Junior developers might find it a lot more helpful than like a 10x engineer, but it's a pair programmer, right? It's the AI pair programmer. Copilot Chat is now GA. This is just using natural language to ask questions about your code. Can you make this more resilient? Can you throw a try-catch block in here? Can you break this module out into its own function, for example, right? Is this an ISO timestamp or an ANSI timestamp? It can answer questions like that. What does this regex do, right? You can just ask it questions like that. Copilot for pull requests, when you commit code and create a pull request, it will automatically generate what all the changes in the commits included in that pull request include, and can even suggest maybe some tests or some people that might want to look at the pull request to approve it. So that's something that your code base would have to be in Copilot in GitHub for. Copilot and Copilot Chat, your code can be anywhere. It doesn't even need to be in a source control. Automatic test generation is also already a feature. You can literally, using Copilot Chat, just say, hey, generate some unit tests for this. You could say generate unit tests in Python, and then you can come right back and say, no, use PyTest, don't use Sonar source or whatever, right? You should just be really precise about what type of test. Maybe you want to do a integration test or a unit test using specific testing engines. We don't have like a code snippet library that we go and search for your code at that time. We just train the AI to understand how to write code in a given platform. And the AI is just as good as any of us are at writing code at that point. Right? So all of these features are actually in market right now. So yeah, we want to make developers have a better time. We want to let the machine do more mundane work, right? Like how do I wire up telemetry to a specific monitoring engine? Just have the machine do all that stuff. If you're updating your code from a different language or a new version of a language and you don't really understand how the changes in like logging or testing work, just ask the computer to write that, right? Let the developers then focus their kind of more menial, kind of less skilled time onto solving bigger problems, right? Developers want to change the world, so let them kind of work on the more strategic parts of the code, right, or changes. And then to bridge skill gaps, if you remember like XP programming and pairs, right? Let the machine be your kind of over the shoulder junior, or maybe even like at the keyboard writing the code while you kind of ask it to just using natural language what to do. And everybody in the organization can have one of these pairs, right? For maybe the cost of a single developer. Great. So we did have a large study of this in 2022. We found like if you're just looking at the time it takes to complete tasks against a control group, people with Copilot can work, right, more than 50% faster. That's great. Usually just a 3% productivity gain is enough to break even for the cost of Copilot. But more importantly, developers seem to enjoy focusing on the more creative parts of software engineering, maybe more on architecture or coming up with more innovation, and they don't have to spend so much time on more menial tasks. All right, Duolingo they weren't concerned about how much time will this save my developers? How much money will I save can I get rid of some developers? No, they wanted to see how much faster could they push commits. And they found that even though the number of commits increased, the time it took to review the code and approve and merge the changes went way down. So they were able to commit more. And for them, that was more important. All right, number 2, CI/CD. Here we're calling it workflows. A lot of people have CI/CD pipelines, but they're not really using continuous deployment or continuous integration. They still have like these long release branches. So we're just going to call that workflows for now, or DevOps automation, right? So we want to think about automating tasks that developers need, not only to build the code, but then also to test the code. Like, do you really need a human to test your code? Deploy your code? Fix it when it breaks? Right? That's really a big part of DevOps and developer productivity as well. So GitHub Actions is our workflow solution. We basically borrowed that from Azure Pipelines. It's under the hood. It's the same exact thing. We divide the kind of post-commit work all the way from building the code, testing the code, deploying the code, maybe even like scheduled tests for load testing or chaos testing. Like we can do all those based on a number of triggers. And then all of the code is described in YAML. Great. I mean, this is basically a new way to describe the automation that you want to use. Not only is there a large library of actions that you can include in your jobs, but you can also write your own actions, right? You can put your actions in the marketplace. We would like to see users, since now the developers are going to be deploying their own code, testing their own code, we would like to see developer teams, product teams, feature teams, whatever you call them internally, we would like to see these teams kind of share their knowledge and success with other parts of the business. All right, so we want to tear down silos and let everybody see everybody else's code. Why build something from scratch if an adjacent team has built something similar? It's kind of hard to do that in Azure DevOps. We generally don't open up all the repos or projects to everybody. But with GitHub, like that's the model. GitHub comes from open source. And in your business, you could have like a walled off version of open source just for your own organization. But everybody can see code, contribute. And we'd like to see software delivery organizations incentivize their developers maybe to help other teams work on their problems. Right? Just like open source. Open source builds great software. All right, so remember, we want to build the code, deploy the code, test the code, fix the code. So the software developer teams can actually stress test their code, maybe at the front end, maybe in middle tiers, automatically for each commit. So think about that. Normally, we would take a whole bunch of work and maybe every, I don't know, planning season or 1 month or 2 months, we would create a new version of the software, and then we would deploy that software somewhere, and then we would stress test it. Here, we can just do that temporarily using ephemeral cloud infrastructure and load test every single commit. So every time we change the software, we can see if those changes introduce, I don't know, problems that maybe they can't handle the same load that they did before. It becomes very easy to troubleshoot which change broke my software, right? When every single commit is tested the same way. Right? Do you even need a test environment at that point? Or I should say, do you even need a permanently standing test environment if every single commit kind of has just a temporary test environment that is created, deployed, and then run through a gamut of like external tests? You can tear all that stuff down once you're convinced that the commit will introduce no more harm to the software than already exists. Right? Um, we have like a gallery of Azure solutions with these deployment environments. So your IT department, or maybe like a cloud center of excellence, might create like a gallery of solutions that developer teams can choose from. You can put all of your kind of corporate policies and safeguards, guardrails into these environments, and then individual developer teams can just go and grab those to work on new solutions as they need them. Right? IT is happy because all the developers are working in environments that meet the corporate standard. Developer teams like them because they don't have to fill out an email or ask anybody for a new piece of infrastructure to release code to. And we shift all that stuff left. And then for a virtual workstation, we do have a solution called Microsoft DevBox. DevBox, you could think of that as like a virtual machine that would have Visual Studio or, I don't know, Eclipse, or really any IDE, like any software could be deployed on this thing. But DevBox does have an advantage over things like a cloud, like a W365 cloud PC. You can have one of these for each project. You could have like a Java version of a DevBox for your Java, maybe like an Angular front end. But if the middle tier is maybe in Go or in Python, you can just stop using that machine and jump onto a machine that has all those tools installed on the machine. All right, so you kind of pay by the SIP, pay a few minutes for the Java environment, switch over to Python, right? Java turns off, use some Python, and then maybe if when you're back working on .NET, you just use the machine that's in front of your hands. Right? Home Depot uses this. Their commits were able to speed up because when people were switching from kind of platform to platform with microservices, they didn't have to load all that stuff on one machine. Sometimes like MS Build requires a JavaScript version that like React doesn't like, right? Or I might be working on an older version of React for my code, but MS Build needs a newer version of React. Like it gets crazy. Right? These temporary developer environments are great. Great. Philip's doing the same thing. So temporary machines, or even your full-time developer workstation, maybe users could bring their own desktop, but then spin up a virtual workstation to get the corporate sanctioned tools at their fingertips. All right, that's great. I'm going to switch over. Derek, please tell me if you can see me switching over to my browser. Do you see my browser? Does anyone see my browser? Ooh, am I still on this? Am I still on this call? I think so. All right. I'm going to switch over to my browser. 1 second. This is me in GitHub. I just have some preloaded up pages real quick for Copilot. Now, Copilot is a tool where it literally like the computer writes the code for the developer or suggests the code for the developer. I'm going to put in the chat window here um, this blog article, and this tells you how to craft a prompt or a comment, how to talk to the machine in a way that gives you more precise suggestions from GitHub Copilot. All right, so this is going to be really helpful to kind of understand how the computer actually sends the request off to GitHub and then to the OpenAI service to get your code suggestions or explanations, and then how to maybe like use the prompts more smartly to work faster. We also have a whole training course on GitHub Copilot with a number of modules, like how to install the tools locally, how to craft your prompts, like how it works on different platforms. It's all free, right? That's great. I want to switch over to kind of that workflow or the CI/CD tooling. And for this, I just want to show one of our open source projects. It's called Kyoto. Kyoto will take any API that it can see an open API specification or a Swagger document for, and it will build locally an entire SDK for developers to be able to code against the APIs. So if someone is building APIs, some remote team is building an API, not on your team, but some other team or some other company or a government organization, and they never built an SDK, or maybe like they built the API and now they're working on the SDK, but the SDK is still old, like the versions are off. Kyoto will look at the APIs that are exposed and it will build right from scratch locally an SDK for developers to be able to consume the APIs better. It's great. Like right now, I think GitHub is building the GitHub API, at least on two of the platforms, entirely using machines and not humans, which is pretty cool. And you can do that locally too. I just want to show like some of the automation. Now, here's the code, and the code is great. I do want to show that inside here, underneath the GitHub folder, and then underneath the workflows folder, here's my CI/CD automation. And I've got a number of different kind of jobs and job steps here defined. But understand now, this is a little bit different than Azure boards and Azure pipelines and Azure repos. Like the dev teams themselves are going to build the code and they're going to deploy the code. So the dev teams now are going to describe what are the build and release jobs that actually put my code into an environment, right? That might be very different than how you're thinking about deploying software. Maybe the devs test it and then they just kind of like package it up and throw it over to the testers. Then the testers test it, and then I don't know, someone eventually will throw it over to ops, and ops will, install the code somewhere in a test environment or a staging environment. Not anymore. We'd like to see devs build the code, test the code, and the testing of the code is done in these jobs, right? Automated jobs. The dev teams themselves will then deploy it maybe into a staging environment or even production. And maybe I have some CI/CD automation that can roll back to a previous version in case something breaks. Or maybe I have automation steps that will respond to a failure in my solution and automatically fix it. Right now, the dev team should be building that themselves because the dev teams are the ones that really understand how their solution is built, architected, right? You got to kind of like move all that stuff left. You got to put all that knowledge into the dev teams, like the people that are actually making the changes to the code. Might be very different than how you're doing it today, but this is modern software engineering, right? The dev teams, the product teams themselves are going to test the code and build the code. And then two, like here I can see all those steps. I can see like every job that is run. Some work, some don't work, some fail. And then I have, I can see like what exactly happened. I can see all the output from all of the jobs, just like Azure pipelines, right? This looks very familiar to Azure pipelines, right? But I get that for every single commit now, I can see how those changes to the code work with my workflow automation, right? With my DevOps automation. I don't have to go look in some other system. I don't have to go from Azure repos to Azure pipelines. Like it's all here right in front of my face. right? And each dev team kind of controls that themselves. We do build a tool called the Actions Importer that will take other CI/CD automation and convert it into a GitHub action, right? This is free. You just install it and run it. We also have another free course to learn how to use GitHub Actions, how to describe the jobs. You can have conditional jobs. If this works, go down this fork, but if it doesn't work, go down a different fork, right? Wonderful. Okay, I'm gonna go back to my slides. We're on number 3 here. Security, right? Security is another thing, not just the DevOps automation, but we also want to take that kind of like security analyst role, and we want to put that talent, that knowledge, at least the desire, we want to put that into the dev teams themselves. Oops, let me go back to the slide. If you think finding developers is hard, wait until you try to find security analysts, right? There's just so few of them, but there's they're definitely overwhelmed by the number of hackers in the world. So there's lots of people who are making money just trying to find exploits and then taking advantage of those exploits. Some are good, right? There's white hat and black hat hackers. Um, the result of both of their work is really not good for any dev team. So we would just want to make sure that all of the research that kind of comes from those hacking teams or the professional security firms, we want to make sure that all of those recommendations end up in your code. Like as you're writing the code, as you're making a commit, we want to make sure that none of those vulnerabilities end up in your software. Okay. Wonderful. So let's say that there is a security flaw in your software. If the devs can fix it, on average, right, it's going to cost $80 to fix it. If you find that in production that there's a security flaw, maybe from like I don't know, a Zed or a burp tool that, oh yeah, we found hiring a pen tester and then finding the actual flaw in production, then it costs a lot more just to hire those people. But if somebody else finds that problem in your production environment and takes advantage of it, then it gets really expensive. So we want to shift left. We just want to make sure that the developers can find those problems, or more importantly, that the automation can find those problems before anybody later on finds it. And remember, the devs are going to do things one commit at a time. So every time a change is introduced to my software, I want to scan it for all these issues. And when it finds an issue, I want the machine to fix it. Right? I don't want to have to stop and rethink how I built, like just let the machine fix it. All right, so we have a bunch of tools that can do that. We'll talk about all these things first. So GitHub Advanced Security is the built-in GitHub tool, and it does 3 things. First of all, it looks at all of my open source dependencies, right? And there's a lot. Oh, hi, Dave Burnison, very famous GitHubber. Everything from like, Angular, React, a whole bunch of libraries that I might use to draw charts and graphs, like a whole bunch of stuff that I use as a developer is open source, built by other people, released in versions, like public versions that I can import as a library, right, or a dependency. So advanced security can look at all of my dependencies, see if whatever version I'm using in my software, see if there is known exploits against it. And if there is, it can recommend what version it needs to be bumped up to, so that there's no longer the exploit risk. In fact, Dependabot, right, that's the little automation tool. The Dependabot will actually it'll create a new branch. It'll upgrade your software dependencies for you, and it'll create a pull request, right? So, I mean, with the pull request, you might also have some testing automation. You could actually get a whole report of, hey, we bumped up the version of Angular to a new version because the old version had a risk. And then we ran a bunch of tests against it. All of the tests have come back positive, right? You could even automate all of your end-to-end testing, right? End-to-end, chaos, load balance. Like you could test all of that stuff with each commit. All right, this next one, pattern-based security analysis. This means it's going to look for anything like a password, a connection string, an OAuth token, right? Anything that would be like just horrendous to have in your Git history, right? Because I don't know, someone can see that stuff. Someone, maybe you don't have it in your code, but 2 versions ago it was in your code and people can find it. And now they have a password or an OAuth token. So we can scan all of your code for any sort of secrets and then take action when a secret is found. Maybe the action could even be if it is an OAuth token or a personal access token, we can go talk to whoever it belongs to and invalidate the token. It'd be better to have your software break than someone maliciously use a privileged token, right? And then we can also scan the software looking for software flaws. So things that aren't known exploits, but are common kind of exploit paths, where maybe something like the OWASP top 10 exploits. We can scan for all those sorts of features. You can have your own rules about features, right? The Apache projects are all on GitHub. Like they're kind of constantly looking for new software exploits. And you can take all the stuff that they find and just run those scanning queries against your code too, right? CodeQL will scan your software for things that very few security experts would be able to wrap their mind around, right? Very advanced kind of hacking techniques. So that's GitHub. Um, what that doesn't really do is kind of show like the central security center, or the SOC, like your SIM tool, like that team that kind of sits in the back and waits, kind of reactively for things to occur and react to it. Like Microsoft Defender for Cloud can also watch your engineering system, all of your Azure infrastructure. It can look for issues that arise out of advanced security. It can look for, I don't know, a container that has an exploit against it, or maybe you built a VM in Azure, but the infrastructure as code isn't really as secure as you'd like it to be, or it isn't compliant or something. Defender for Cloud is a good tool for those security teams to see what's happening with the software and the infrastructure as well. So whereas GitHub has a bunch of these tools just for developers, we would normally pair that with something like a Defender for Cloud to give the security teams information about the software or the infrastructure that it's deployed to. That same like scrutiny, right? And so here we just see like it's very Azure looking, right? We would have a number of maybe incidents, and then you can kind of drill down into those incidents a lot like maybe like a Sentinel or something. Right? Azure Monitor is also great, but this would be like maybe you introduce something in code, and now for whatever reason you have a memory leak in your code. Like Azure Monitor finds all that stuff. Right? Maybe you'd roll it back. Oh, this is my favorite slide in the whole thing here, because it's a Norwegian company. Gjensidige basically means mutual, or like I help you and you help me, that sort of thing. So this is a customer that uses Defender for Cloud, and they add that to GitHub Advanced Security so that the security teams can see what the developer teams are finding in GitHub Advanced Security. Normally, I don't want my security team logging into GitHub and looking at what the developers are doing. Like there's not enough security people. But if I could send the telemetry out of GitHub or Azure DevOps over to Defender for Cloud, that's, I think, where the security teams really want to see incidents and be able to react to incidents. All right, and then finally, oh boy, this then builds an entire engineering platform, right? All of the tools are here. Everything from planning the code, writing the code, testing the code, sending it off to its the infrastructure that it lives on, whether that's in Azure or some other cloud or on premises, and then being able to see like what is the result of the code changes to the actual software. Like all of that would be in GitHub for the developer teams. I don't have any third-party products where, I got to log out of, or maybe not log out of GitHub, but I got to go log into some test tool or some, I don't know, some sort of scanning software and see the results over there. Like what we like to see is that everything is in that commit, or more precisely, the pull release discussion. So let me switch over to explain kind of what that means. If I kind of come down here, all right, this is GitHub, right? Nothing strange here. But Tesla Motors is something that I follow. It's actually one of my customers. Tesla Motors also has a pretty big open source presence. And they have this project here. It's just like, they have cars and the cars all run on software. And when they do a software update, they want to manage the release of those software updates to the, however many hundreds of thousands of cars are out there. They just want to make sure that they have like a rolling update across the whole fleet. And this is open source. So like all the other car manufacturers can watch this and maybe implement some of this stuff themselves. It doesn't even have to be a car. It's anything with like a remote software update. It kind of takes advantage of like some cloud infrastructure just to make sure that that whole update process goes smoothly. And if I kind of click through here, right, so I've got the code, but then, sometimes people say this is broken or I wish it had this feature. And so then from the issue, I might create some, I might change the software to fix the issue. And then when I'm done fixing the issue, I would normally create a pull request saying, would you please merge my changes into the code base? Right. So if I kind of click on this, this is the pull requests. And if I filter on just the closed ones, I can see like, what did it take to actually merge this code into the code base? So these are closed pull requests, right? For an open source project, there's nothing hidden. This is nothing secret, right? This is a public project. If I kind of click on that, I can see like this conversation. And this is really nice. It says like a whole pull request template. It's very nice. Like Tesla always goes through these steps whenever they merge code, right? It's a very nice pull request description, hint, hint, right? And then we have a discussion like people might approve it or people might, I might running through some testing checks and stuff. I can see all the commits. So I can see all the code changes that participate. Many times there are more than one, right? The more commits, the more kind of complicated this merge request will be. And then I can see all the tests that were done to actually get humans to agree that yes, this software update or the changes in this software are safe enough, we believe, to merge into the existing code base. So this is just GitHub Ads. This is another way to kind of see for each commit, on a commit by commit basis, I can see all the results of normal build and test. Right. So here I got, what do I got? Right. These are all like some Go language testing stuff, right? And then if all the tests, I can click down further in here and see like what were the actual steps it took on each one. Here's the actual test, right? So it might talk about like the output from right, all of the all of the Go language testing stuff, right? Let me go back. Here's code QL. So then this is the code scanning. So I can scan the code for any exploits for each commit. I don't wait until I get a bunch of commits and then do security chaining. Like every single change to the software goes through the code changes, right? So I can see all the output, or I can see all the steps for this job, right? Set it all up, build a code QL kind of database, and then build the code, and then watch how the code performs with a bunch of queries, and then see all the output and stuff. So every single commit has this. And if I have this wired up to for Defender for DevOps, then all of my security professionals see this too. If something doesn't pass one of these security checks, like they're going to know about it right away. But each pull request then is kind of subject to all of those security scanning, secret scanning, vulnerability scans for the dependencies. Every single commit goes through that. So every time I change the code base or, want to introduce changes to the code base, it's run through the gamut of tests, even the security scanning that usually would be done by pen testers, by expensive pen testers. Now, every single commit to the code base goes through that same process. I shift all of that security stuff left at a much cheaper cost, right? Like, let me go back to one of these jobs. Hold on. All right, I don't have the whole list of time, but if I look at just like code QL, like this is literally, let me just click on this one more thing. all the steps. Like this is 2 minutes. This is less than, this is like a minute 45 seconds. In a minute and 45 seconds, I can make sure that the code changes that I'm about to introduce into the system are completely safe, right? Safer than I could probably figure out by hand or doing a code review with very skilled engineers, right? So we would say, yeah, shift all those responsibilities left, let the machine do it, let the developers focus instead on, more innovation and stuff. Right, so those are the 4 points, right? The 4 points of this presentation. All right, remember, there's a single Microsoft platform. It's Visual Studio, and that doesn't mean the Visual Studio IDE. Feel free to use VS Code. In fact, if you look down at my, I don't have it open right now. I don't even have Visual Studio on my desktop. I have VS Code. I love VS Code. But yeah, Visual Studio also has some benefits for VS Code users as well, a Visual Studio subscription. So use Visual Studio subscriptions, use GitHub. Microsoft builds more and more on GitHub. Azure DevOps is not deprecated. In fact, we would love it if you used GitHub with Azure boards, right? There's nothing else really matches like that planning and reporting capacity of Azure boards. And then deploy your stuff to Azure, right? There you would get things like Defender for DevOps, uh, Azure load testing, Azure Playwright testing for end-to-end, kind of like the user acceptance tests, all automated, Azure chaos testing, just some good tools, right? Oh, well, here, they're going to tell me what I just said, right? Visual Studio is great. VS Code is great. I love VS Code. So if you put all of this together, right? If you use Visual Studio, GitHub Enterprise, Azure, and then more importantly, if you adopt kind of this new software delivery mindset where we really have the developers planning the code changes, building the code changes, testing them, deploying them, and when those code changes break, actually fixing the code changes, it's not just a benefit in the speed to which you can introduce new features, right? Obviously, like DevOps makes the developer velocity faster, right? That's well known. But the companies that employ those processes perform better financially, right? So even if you were to drastically change your software engineering platform, you would pay this off in a short amount of time, months, right? To do all that work, and you'd see huge returns on that investment, right? If you're building any sort of software, like you probably won't find similar ROIs anywhere else. I mean, like we use this stuff ourselves. GM is another good customer of mine. They did use Azure DevOps. They switched over to GitHub. They use Copilot, and they also use DevBox, right? So they use developer workstations, virtual. They use all those together. They've sped up the speed at which they could release new features. The cars themselves all share like a common software version. All the cars across all their lines, like Buick and Cadillac. That's a well-known case study. In fact, they were on stage in 2022 talking about their work. Right. So this is what we're saying. Use our platform, but also like think about those 4 things, right? Let the AI write the code, automate the testing, like get rid of your test departments. Microsoft got rid of its test departments. It took us 5 years to automate our entire unit, end-to-end, smoke testing, integration testing, chaos testing, all that stuff we rewrote. It took us 5 years to do that, but we've entirely eliminated that from our organization. There's no testers here at Microsoft. We've just, that's a responsibility of the engineers themselves, right? They write the automation. Like we have test-driven development, right? So just write those tests and then write the code. Shift all the security policies and everything left. The developers are now responsible for that. And most importantly, make sure that everything is done in that pull request kind of discussion, right? The pull request should be a discussion about the changes that are about to be introduced to the code base. So make sure that all of the tools not only link to that discussion, but put the test results right in pull request discussion, right? Let any human approver just kind of quickly scan down that, scroll down the pull request and be able to quickly see, yeah, this is either safe or maybe we need to invite more people to discuss it. That's it. Not only am I going to put those links in the chat window, but we also have like we've got these enhanced solutions from our unified group. Let me switch over to that real quick. Down here, we've got like these engagements or the types of offers that we have. We can help you migrate to GitHub. We can help speed up your developer velocity. We can support developers by maybe migrating from on-premises to the cloud. We can take existing IaaS solutions and make them a more PaaS solution, right? Build and modernize with AI. So these are offers that we have. If you have unified support, many times like those come with a set of hours that you can use. Like you can use these hours for some really, really beneficial things for your engineering department, right? Including like how to convert, oh, I don't know, I'm just going to make this up, Jenkins to GitHub Actions, right? So all that sort of stuff we can help you with. Get in touch with your Microsoft account team. Many times you already own a number of hours that you could distribute to this. Your account team will be able to like send you all these documents if you want. But that's all I have. I think I'd like to open this up for any questions if there are. Otherwise, I'll start putting those links. I'll stop sharing and